I'm joined with a very interesting guest today. I'm excited to invite him. Animesh Singh is here to talk to us about Kubeflow, and I'm going to introduce Animesh in a minute. But before I do that, I just wanted to send a special thank you to our sponsor, IBM. IBM has been supporting Data Council this year, 2020, throughout our online events and community, meetup community. And so we're very excited to have their support. IBM is a big supporter of the open source community, and they have a special data science community with online resources, content, and support for data professionals. And you can check that out at the link that we'll put in the chat alongside this episode. So do check them out. I know they were offering a free online course for registrants. So I hope that you'll take advantage of that and enjoy the resources that they have on display there. Secondly, I wanted to just do a quick announcement and mention to folks who are listening and tuning in that if you haven't joined us before, you know that, or you might not know that this is a bit of a special format where we encourage folks to ask questions in the chat alongside the broadcast as I'm chatting with Animesh. So please come prepared with your Kubeflow questions, and we'll try and fit them in. Usually we get some great questions, and it helps us sort of shift and move the course of the show. So it's appreciated, and we want this to be a dynamic two-way resource and medium. So please feel free to type in your questions that you have prepared. Finally, as a final note, if you want to be notified of these episodes when they stream, obviously we send out emails, and many of you are on our email list and have signed up for these sessions previously. But if you want to just go through the YouTube plumbing, you can do that as well, and you can make sure that you're a subscriber to the Data Council channel. And there's also a little bell icon, and if you click on that, you can actually set your notification level. So you can be notified every time that we go live with a new DC Thursday, in case you want to be notified in real time and tune in that way. So as I mentioned, Animesh Singh is here, and Animesh has had a pretty amazing career at IBM. You spent at IBM for 15 years. Animesh, now you're the chief architect and program director for the AI and ML platform. And of course, you're working on Kubeflow, which we'll talk about, but I know that you've had meaningful contributions to Kubernetes, the Kubernetes ecosystem. You're also involved in AI ethics and other important topics right now that are very timely. But I just wanted to hear a little bit from you, like tell us a little bit about the story of your career at IBM, and how has that morphed and changed over time?
Yeah, thanks, Pete, and thanks, first of all, for having me here. It has been a great journey at IBM, right? Obviously, 15 years is a long time, right? But by virtue of, being in a part of IBM which has always been at the forefront of cutting-edge technologies, right? It has been constantly shifting in terms of, the technologies. I mean, I started working on cloud when it was in very early nascent stage. The journey with IBM and with customers on first, set of private cloud products, both on the infrastructure as a service space, platform as a service space, then moving towards, public cloud with Blowmix, which was based on top of Cloud Foundry, right? So that also was the time, right, where, there was a strategic shift in our part of the group in IBM, right, to do more and more on cloud with open source. And as part of that, right, Cloud Foundry was one big technology which we adopted. So I played a big role in that, and IBM invested heavily in terms of creating a platform as a service on top of Cloud Foundry. And then, the journey moved on until, Kubernetes came in. And I think that probably was the time, right, where I sort of realized I have done, spent enough years in the cloud. It's probably has reached a sense of maturity where, the next big innovation, so to say, is probably, years away. So, data and AI started exciting more. And that's where, I started working more on the data and AI side of things. And I've been leading, quite a large number of efforts within IBM around distributed training platforms, model serving platform, model management and governance, AI ethics, as you mentioned, around fairness, adversarial robustness, explainability, and also working very closely with Red Hat, right? With the acquisition of Red Hat, the importance of open source within IBM has obviously gone tenfold more.
Mm-hmm.
Right? So there is a lot of activity where we are ensuring that the basis and the basic open source technologies which we are adopting, right, are sound. We are aligned, and we are working together and jointly in terms of growing them. So yeah, that in short summarizes the journey on cloud and data and AI side.
That's great. Well, we've had IBM speakers and participants at our community over the years. I think before your group was called Kodai, it was the Advanced Spark Research Center or something to that effect. And I know we had some great committers to Spark and others who have joined us over the years. So it's been a great relationship, and I'm glad to have you here, and thank you for taking time to talk to us.
Yeah, and just a bit on the group, right? Definitely. I mean, it previously was called Spark Technology Center, right? So yes, there was a strong motion, towards Spark, and we still have, quite a bit of committers and contributions towards Spark, right? But with Kodai coming into picture, Kodai stands for Center for Open Source Data and AI Technologies. With that coming in picture, the mission has expanded to the whole data and AI life cycle, right? So we contribute to projects like TensorFlow, PyTorch, Kubeflow, around trusted AI ethics, but then also around things like Egeria, which is a metadata governance data catalog, which is becoming very popular in its own right. So it's spread across projects, across the data and AI lifecycle, and there are significant contributions. We are currently, the second largest contributor in Kubeflow. We have been at many a times for many Spark releases, the second largest contributor to Spark, fourth largest contributor to TensorFlow, right? So there is, strong sense of contribution from the team, right, in open source around data and AI.
That's great. Well, let's use that as a segue to talk about Kubeflow, because as you mentioned, Kubeflow is a industry-wide, supported by an industry-wide consortium of amazing companies. And IBM has significant investments and contributions, as do Google, Microsoft, Facebook, Cisco, Bloomberg, so many folks. I think it's quite remarkable because not many open source projects that I'm aware of have so much support across so many different types of cloud vendors and folks really betting on AI and machine learning and the future of data in their businesses. So it's a pretty amazing group. I'm sure sometimes it's like herding cats and it's hard to like get everyone to agree and move forward. According to what I read, Kubeflow was open sourced officially in December 2017, but you just had a 1.0 release in March of this year. So congrats on that. I'm sure there's some story about like, what went on behind the scenes, and when the engineers beat themselves over, beat each other over the head to know that it was ready to ship instead of just, continue to fix stuff. But anyway, I'm kind of interested to hear how Kubeflow came to exist and what the background story of it is, since I know you've been involved for quite a while.
Yeah, no, pretty interesting, right? I mean, a lot of the right points you touched, right? So it was December of 2017, KubeCon, right? So where David Aronchik, if you folks don't know, right, he was in Google, a strong force behind Kubeflow, and currently, working in Microsoft, right? So he was giving a session at KubeCon around, running TensorFlow on Kubernetes, right? I mean, so Kubernetes is hot. TensorFlow was becoming hot at that time, right? And there was this problem to be solved, right? How to get, scalable TensorFlow running on top of Kubernetes, right? So when you're doing distributed training, you have out-of-the-box integration, right? So that in essence was, the crux of the idea, right? It was a session, a demo that, hey, if you want to run TensorFlow on Kubernetes, right, this is how you get started. And then slowly it started expanding, right? In a sense that, the adoption and maturity of Kubernetes started going, many folds. A lot of enterprises, a lot of Fortune 500 companies, started standardizing on Kubernetes. A lot of cloud providers, right, started standardizing on Kubernetes. And then, the problem then shifted to, okay, we need to run, machine learning and AI workloads on top of Kubernetes. So even though, the origin was with TensorFlow and Kubernetes, it quickly expanded. Okay, now let's bring PyTorch. And then, there are community members who wanted scikit-learn, XGBoost, right? So that started, forming a conglomeration, right? Which is, okay, if you need to run, distributed training on top of Kubernetes using these technologies, hey, Kubeflow is being positioned there. But that's where it didn't stop, right? Obviously, training is a very big and important part of the life cycle, but there are things which need to happen before training and after training, right? So things like, a lot of the times, data scientists, they start their work using something like Jupyter notebooks, right? So initially we started with Jupyter Hub. At some point along the journey, we decided to phase out Jupyter Hub and rewrite and have Kubeflow's own implementation of launching Jupyter notebooks on top of Kubernetes. So that became one project in itself. And then, it started shifting towards the rest of the umbrella, which is, okay, uh, you have a way to start creating your models, running distributed training, but then, you need to deploy your models in production, right? So that's another interesting story. I gave a talk at KubeCon December 2018. That was a year after, Kubeflow was launched. That time, Knative has been recently launched, and we were exploring in terms of running serverless model inferencing, right, on top of Knative. So the talk at KubeCon was, focused on this area. If you need to leverage Knative, right, as a serverless model inferencing platform. And very interestingly, Ellis Tarn, as he's known now, right, he was also attending that talk. He was in Google, currently, part of Amazon. And, he came and said that, he has been thinking along a similar lines. In parallel, Bloomberg was, also exploring serverless model inferencing. Selden obviously was pioneering, machine learning graphs. Microsoft was in the process of, moving Azure ML stack on top of Kubernetes. And then we had, Google itself doing a lot of work around TF-serving, TensorFlow serving. So I think we decided, okay, let's come together, form this, group, so that, we focus on this problem together of, machine learning inferencing on top of Kubernetes and geared towards 80% of the use cases, right? So that led us into the serving side. So, there is notebooks now, there is distributed training, there is model serving. And then, you need something to bring all these things together in a more headless, automated fashion, because for a lot of the cases where, data scientists are manually interacting with these tools and platforms, there are, in fact, more number of cases where you need automation, right? Where these things run in a seamless loop, right? So that's where, Kubeflow pipelines came into existence. And at this point, needless to say, is probably the most popular product or project, as part of the Kubeflow umbrella. So yeah, it kept on evolving. And yes, as you mentioned rightly, just March of this year, right, we had our formal 1.0, and we wanted to go last year, December out, but it's dotting the i's, crossing the t's, ensuring that all the stakeholders are happy, which led to the launch. Thanks.
Got it. Well, I think it's really interesting that, as I mentioned, it represents all of this cross-country or cross-company collaboration. But I also want to just reflect on the fact that Kubeflow is really it's not an open source technology in and of itself. It's a collection, and I mean, it's more than an orchestration layer, but I think the orchestration layer becomes a key part of what it's all about. So, but really, Kubeflow is representative of, or includes lots of other open source, best of breed open source projects as well. So I want to sort of pull up this diagram that I have that I pulled from one of your talks to really sort of articulate what the Kubeflow system looks like. And Animesh, let's talk through this for a second, because I want to make sure that people have an understanding of kind of all the different things that Kubeflow covers and a bunch of the different open source projects that it encompasses or can be pulled into it and integrated with it as well.
Yeah, no, thanks, Pete. So obviously, I mean, this is, in this chart in some ways, depicts the problem as well as, why something like Kubeflow needed to exist, right? So on one hand, right, the open source landscape around data and AI has been exploding, right? So you see a lot of great projects coming around. I mean, obviously, TensorFlow Serving, has a strong momentum of its own. There is PyTorch, XGBoost, and Scikit-learn have been out there for quite a while. And then, there are, the problem started shifting towards, I don't have a solution for that in open source, to, hey, it looks like there are too many choices. Plus, I need to run all this on Kubernetes, right? I need to establish one single standard data and AI platform on top of Kubernetes, right? And how do I bring all these technologies together? Which ones to choose? And then orchestrate them together, right? So it's not only, deploy them, but, we need a consistent layer to work through them and have a seamless transition from build to train to deploy to manage, right? So in and it itself, right? I mean, as I mentioned, right, the core origin was, let's run TensorFlow on Kubernetes in a scalable manner. Then, moving towards where other open source projects exist, right? So all the distributed training operators which you see here around, beyond TensorFlow, it's PyTorch. Then there is MXNet. There is also Chainer, right? Depending on the geography you are in. If you're in Japan, for example, you will see Chainer very popular, right? So that's also available as a distributed training operator. And then there is an MPI, which is based on Uber's Horoward approach for doing distributed training, where you have more peer-to-peer syncing of the weights and the gradients, instead of using, the TensorFlow's parameter server approach, where you have, a parameter server which is responsible for synchronization of the weights and the gradients. So distributed training became, quite a bit of field, right? And, this is a challenge which was being faced by many vendors, right? Hey, there are some users who want to use TensorFlow, some who are using PyTorch, some who want to use Chainer, some want to use this algorithm for distributed training in TensorFlow versus the TensorFlow's native algorithm. So that's, was a problem, for solved by the distributed or the training operators. As I mentioned, right, I mean, before training, you need a build platform where you can have your initial models written, debugged, etc., right? So that's where Jupyter notebooks come into picture. And again, this is, instead of taking, Jupyter Hub as is, the approach here is to actually provide our own implementation based on a Kubernetes custom resource architecture for Jupyter notebooks. What we have seen is, it has done much better in terms of scalability, working, nicely with the underlying GPUs, persistent volume claims, etc. So far, very, very popular part of Kubeflow as well. So you have Jupyter notebooks to build, you have training operators to train, and then, we go to the serving side, right? So then you have to deploy your trained models, right? So what are the options there, right? So, there was TensorFlow serving if you are, using TensorFlow models. Some folks are using, for example, Onyx. So they are, training in TensorFlow or PyTorch and converting it to Onyx. Seldon has been, out there and has been very popular in terms of, providing model serving on top of Kubernetes. And then, as I was describing, right, KFServing, which went in with the notion that, models consume heavy resources, they consume GPUs, these are expensive resources. And if your models are not getting traffic, thou shall just, scale back to zero. They should not be consuming infrastructure. And the second thing is, how do you do canary rollouts, A/B testing? So that's where, Kubeflow serving got focused in. And so now that you have all these different building blocks, how do you bring them together, right? How do you orchestrate them together in a more automated, headless fashion? So Kubeflow Pipelines, fulfills that particular gap for us, where you can actually go through the whole life cycle and, run distributed training, validate your models, deploy your models in production, launch scoring and monitoring clients using pipelines.
Okay. And did I read, Animesh, that Pipelines is built on Argo behind the scenes?
Yeah, so that's Definitely, another story. So I'll go into it as much. Definitely, the default Kubeflow pipelines engine is built on top of Argo, another solid open source community project, right, which came out of Intuit, right. So as I was trying to complete this story, right, so you have build with Jupyter, train with all the distributed training operators, TensorFlow, PyTorch, XGBoost, MXNet, Chainer, MPI, and then serve using Kubeflow Serving or Selden Core, right? These are the two core serving platforms, and Kubeflow Serving brings different runtimes, right, for TensorFlow, PyTorch, XGBoost, Scikit-learn, Onyx, NVIDIA's Triton, all together in a single serverless platform on top of Kubernetes.
Mm-hmm.
You have these basic platforms, Kubeflow Pipelines, right, which is built on top of Argo by default, started providing capabilities to orchestrate them end-to-end machine learning lifecycle. And that's where also our interest in terms of beyond open source contributions, right, where we wanted to standardize in terms of the pipelines, right. So Watson has been engaged heavily in terms of creating our Watson AI pipeline story on top of Kubeflow pipelines. One thing which we have done is there is a heavy strategic alignment within IBM around Techton as the underlying CI/CD technology. IBM Cloud CI/CD is based on top of Techton. The OpenShift pipelines is based on top of Techton. So we rewrote the whole Kubeflow pipelines core to actually work on top of Techton instead of Argo. So it has less to do with the technical capabilities of the two platforms, right? I mean, it's not to say, hey, this is better or this is better. It's more that for us, it made a lot more strategic sense given that we have already standardized on Techton as the underlying CI/CD technology across our cloud and cloud native landscape. So we rewrote the whole Kubeflow pipeline engine to use Techton. And for
Just to clarify, that's Techton, Tekton, right? Not Techton, the feature store that came out of Uber. There's so many funny name collisions in the space, so many flows, TensorFlow, Kubeflow, MLflow. I just wanted to clarify that it's Techton, Tekton, correct?
Yes, you're right, Pete.
Okay.
And by the way, I mean, one thing which is not, now that you brought up feature store, right? One thing which is not mentioned on this chart is, there was a partnership initially between Gojek and Google, where they launched, Feast, which is feature store. And that's a project, which is now heavily being driven by the Gojek team out of Singapore, right, at this point. And it has become very popular in the feature store space. In fact, the Uber's Techton has had a strong collaboration with, Willem, who is leading the Feast project on the feature store side. And it's also available, as part of the Kubeflow install as well.
Oh, great. That's good to know. Yeah, we'll have to update this this graphic to reflect that.
One last thing I do want to highlight is now for more advanced customers, right? Assuming you have all these in place, right? You have the different platforms to do the heavy lifting around distributed training, building your models, serving your models. You have pipelines to orchestrate that. More and more advanced customers are now looking at, governance, metadata, lineage, right? So it's not only sufficient to take me from point A to point B, right? In machine learning world, the final outcome is, a model deployed in production, but how is that model behaving in production is in fact, more important because, you're not guaranteed that, the same model with the same input 2 weeks later will give the same output, right? And we have heard situations, and you probably would have heard, Pete, that, quite a few people have lost their jobs because, the models which was deployed in production, right, started doing something which it wasn't supposed to do, right? And that's where, having strong and robust metadata auditing and lineage capabilities become very, very important. So, there is the metadata project, which is backing Kubeflow pipelines, right, where you can trace down the lineage of every deployed model right back to the point, right, okay, this was the initial data set, this was, the change schema for this data set. This is, the new set of features which have been added to this data set. This was trained using TensorFlow version this, and then, using these hyperparameters for hyperparameter tuning, and then finally, deployed on this. These were the scoring characteristics, right? So in case, of any trouble, or there is good news, but most importantly for your compliance and auditing needs, you need to be able to trace back to the very point, like, what actually formed this model, right? So the metadata project backing Kubeflow Pipelines gives you this whole capability to trace back the lineage, for your deployed models in production, right? At every single step, going back all the way to from where you started.
So that's the metadata component here on the left of the diagram.
Yes. Yes.
And is there a model registry that's part of that, or how does Kubeflow handle that aspect of it?
So model registry is surprisingly an area where we don't have a quite at this point an implementation out there, right? Definitely, it has been a strong request from the community, right? So the metadata registry is there. The metadata registry is more generic in the sense that all the metadata around your data sets, models, but having the construct of a model registry where you can actually store the model bits and the bytes, versions them, etc., right? That part is yet not there. There is a special interest group which has been formed, which is looking into it. Quite a few members of the community are, right, intermingling this and bringing MLflow model registry to work with these technologies, right? So I mean, that's always, we are seeing architectures where you have model registry projects out there in the open source community, and folks are building their own reference architecture, combining the different parts of the Kubeflow technology with those.
Got it. Well, that's quite the sprawling ecosystem. I mean, I think it's remarkable that you're working to cover so many corners of the machine learning workflow in one platform. I mean, obviously, the idea is that the whole system runs on top of Kubernetes. So a company basically has to be bought into Kubernetes in order to make use of this. And of course, if a company isn't in Kubernetes, there's sort of point solutions for a lot of these functional pieces in other in other parts of the open source world. Some are very simplistic. Some are more built to be designed to have systems built around them. But I guess on that note, just in terms of sort of rolling out Kubeflow, I'm curious, besides the Kubernetes requirement, are there other sort of indicators that you see that tells you whether a team is ready for Kubeflow or not? I mean, do you have to implement the whole thing, or is there an easier way to kind of get started with just bits and pieces of it? What do you see in terms of how new users basically get onto the Kubeflow platform, and when is the right time for them to start to consider a framework or system like Kubeflow?
Yeah, very good question. I think, it's a very mixed landscape, right? I mean, so the users who are coming, right, there are some who are much more advanced in terms of, some decisions they have already made, right? So some users have already standardized, for example, on Jupyter Hub as their Jupyter facing platform, right? Or some users who have all actually, gone ahead and have, partnered with a vendor for a distributed training platform, right? So it's the point where you are in the AI lifecycle, right? So quite a few users who have, done more advanced scenarios, they are coming for the latter part of the lifecycle. Okay, I have the basic infrastructure for building my models and training my models, but I need, a platform to deploy my models in production, right? And I need more automated, pipelines to actually orchestrate this. Now that we have the end-to-end platform coming together. Plus, since we are moving more and more models in production, I need more advanced metadata and lineage tracking capabilities for auditing purposes, etc., for compliance. So, but then there is a huge set of users, right, who have probably, at this point standardized on their cloud infrastructure, have made a decision that, it's Kubernetes or OpenShift, right, as their underlying platform for any other workload they want to bring on top, right? And even though they have bits and pieces running, they are looking at, can there be one turnkey solution, right? Instead of, spending a year to build my distributed training platform, spending next year to, set up a model serving platform. Then, the last year is, when I look at metadata and lineage tracking, is there a way to actually cut that cycle, right? Can I standardize on one thing and make that 3 years go in 1 year, where by the end of the year, I have a production ready system in place, right, which is handling all the parts of the life cycle. So many users actually are coming from that perspective, right? Now, so these are, the consumers. And then there are vendors, right? So people who are trying to package and resell more advanced solutions on top of Kubeflow, right? So they're also, you see, like specifically for us, like within Watson, right? As I mentioned, right, the two areas which are of supreme importance are pipelines, right? That's an area where we are actually investing quite a bit in Kubeflow. As I was, describing, the second area where we are actually, investing quite a bit is serving, right, and more so serving in the serverless world, right, which is essentially, if your models are not consuming resources, they should scale down. And we have high scalability requirements in terms of that. So we are working on the KFServing community, right? Besides being a co-founder, we are amping up more and more contributions in terms of building and bringing it closer to what we expect from a Watson perspective. And then there are different vendors who are actually packaging and reselling the whole Kubeflow as is, right? So you see, all sorts of flavors happening. Yeah.
Got it. Well, let's dig into one of these components a little more deeply. You mentioned the serving component was an important part of the whole Kubeflow ecosystem. What are the advantages of using Kubeflow or KFServing? Why would I use that versus some other serving technology that I could use if I was deploying my models? Maybe walk us through some of the advantages of how the KFServing piece of it works and what engineers should look for in terms of benefits there.
Yeah. So I think the first and the foremost reason is like, are you in a situation where, you are seeing more and more models rolling into production, right? So when you see more and more models rolling in production, right, the things which you need to account for is, hey, is the resource overutilized? Is it underutilized? I mean, most of your models are probably, consuming expensive resources like GPUs, etc. So you want to make sure that, you're prioritizing, the models which are getting more traffic versus the ones, right, which are probably, sitting idle. Then there are things like, can I support multiple protocols? Can I support HTTP? Can I support gRPC? Right? Do I have support for multiple frameworks like, I have TensorFlow models, PyTorch models, ONNX, Scikit-learn, XGBoost, PMML, right? The list goes on and on, right? If I deploy these models on these platforms, right, can it actually leverage the underlying GPU infrastructure in the most optimized manner? Then you're looking at capabilities like, canary rollouts and A/B testing. Right? Because machine learning world is so experimental in nature, you will be producing more and more models at a much shorter frequency, as opposed to the application world where you're probably doing, quarterly rollouts, right? If you're very agile. And they are supposed to be constant, the same input to the same application is guaranteed to give the same output, 3 months later. Not so in case of models, right? So you're doing, many rollouts. So, having strong, robust capabilities to do canary rollouts. And while you are doing them, right, being able to do traffic splitting and traffic routing, right? So you probably want to be in a situation where you are rolling out new versions of the model, probably directing 5% of the traffic, and then, incrementally increasing it, looking at the metrics, right? And as the metrics are making sense that, okay, the model accuracy is good, there is no drift, you're then, amping up the traffic where you make the canary the default. And, the last leg, which is, okay, now that, you've figured out everything, how to deploy this model in production and do progressive rollouts, do traffic splitting. And when the model is not getting traffic, you can scale back to 0. Then, okay, how do I capture more advanced metrics, right? So some of these are, more, I would say, traditional infrastructure level metrics like CPU, GPU consumption, but then, you start moving up, the request per second, the latency of the model, but then more advanced machine learning metrics, right? Is the model showing a drift, right? Is there an anomaly? Are the model predictions getting biased? Can the model detect adversarial attacks, right? All these more advanced capabilities on machine learning side, right? So, and then there is another piece, right, which is most of the models, right? They typically have a pre-processor and a post-processor. right? So that means, like if you take a look at the core model code, it's a predictor, right? Which takes, for example, tensors in and gives you tensors out. And for all practical purposes, that's the thing which needs GPU. That's the thing which needs heavy compute power. But then, your pre-processing code, which takes, for example, an image from an end user, converts that image to a tensor. And then there is post-processing, which, gets the response from the model, which is again tensors, converts that to a text. They're all bundled in the same, they're all consuming the same GPU, and which is a problem, right? I mean, these pre-processors and post-processors can actually run on, cheaper CPUs versus GPUs, right? So does your platform provide those capabilities? So many of these problems which existed, and that's what we are solving with KFServing, and so far we are getting very good feedback around solving some of the real hard production level problems with KFServing. Yeah.
And I wanted to ask about the metrics and the sort of monitoring of your models. Does KFServing have some standard way of instrumenting models for performance metrics, sort of evaluating the model quality? What is that monitoring? Does that monitoring component plug directly into KFServing, or is that a different piece of the Kubeflow framework?
It's a good question, right? So by default, right, so the KFServing stack, right, it's built on top of Knative, right? Now, so that means, out of the box metrics. So Knative has a very good ecosystem integration with Prometheus and Grafana, right? So a lot of the out of the box metrics around, request tracing, request per second latency, you get out of the box. You can go to your Grafana dashboard, you can start seeing those metrics, as and when, you deploy KFServing along with these monitoring stack. Now then comes, the more advanced metrics, which are, more machine learning specific metrics. So all that's talking about drift, anomaly, and bias detection, adversarial detection, right? So that's something which we have what we have done in KFServing is we have implemented using the standardized CNCF eventing protocol, right? So you should be able to capture your payload logs, right? So like most of these things, as you see, like if you're predicting there is a drift, you're predicting there is an anomaly, or you're predicting there is a bias, more often than not you require a bunch of historical data versus just making a decision based on that one single transaction, right? So that's the thing which needs to be captured, right? So if your model serving platform is deployed, it should be able to capture the request coming in, the responses going out, and then it has a history of that, and based on that you can run analysis for drift, anomaly, and other things. So for that we provide a standardized implementation using the cloud event CNCF protocol, which you can configure to send your payload logs and persist it on a Kafka or a Knative broker or a database, right? So it has all these capabilities where you can persist this. If you are persisting these logs on your storage mechanism of your choice, then we provide advanced algorithms, right, to run on top of those payload logs, right, request responses, to give you analysis around drift, anomaly, bias detection, adversarial detection, and things like that. So it's the last leg is a bit more work. Now, can we package something which is, let's say, make a default choice for the persistent storage within KFServing itself? Yes, I mean, there have been thoughts, like, but more often than not, you would see when customers are actually deploying something like this in production, they would have a storage of choice, right? Hey, I already have a relational database running in production, or I have a Kafka eventing stream running in production, and I would like these to be sent there versus you bring a storage solution. So that's something that you don't bundle out of the box, and maybe we should there have been thoughts around should we create one advanced installer if someone wants this out of the box persistent storage mechanism, right? We provide. Otherwise you're free to configure on your own.
Got it. And is there any interface at that point between any of the ethics and fairness projects you're working at on IBM? Do they integrate into the Kubeflow system at this point, or are they completely separate projects?
No, in fact, we just, last month we did a PR and have integrated AI Explainability 360, which is now part of the Linux Foundation AI umbrella. And a very popular project in its own right, in terms of we have been using with a lot of financial industry customers. So now that's available out of the box in KFServing. So if you deploy KFServing, and you want, explanations on your model
Great.
collection, right? And this can work at a per transaction level, right? This is one of those things which doesn't require a historical sets of input and outputs, right, for you to be able to generate explanations, right? Obviously, there are algorithms there which can do that, but it can work on live individual transactions and give you explanations. So that's integrated. The second project which we are essentially, working on, and hopefully, we'll have a PR in the next few weeks, is around adversarial detection, right? So there's a project in the Next Foundation AI called Adversarial Robustness Toolbox. This is something, which we are working with DARPA, right? They are using it as part of their defense research. It's also, being used by Microsoft, General Motors, right? So that's one of the projects which we are now integrating in Kubeflow Serving, right, to do the detection on your inputs, right? So our inputs which are coming, are they adversarially impacted, right? Is somebody trying to fool the model to get detection? So yes, definitely. I mean, that's an important stream for us to make sure, these come out of the box. So explainability is already there. The next one in the line is adversarial robustness. The last one which we will integrate is AI Fairness 360 for bias detection and mitigation.
That's great. Well, these are some really advanced, important aspects of this ecosystem that we're all helping to create, especially the ethical fairness, bias detection, adversarial hacking detection. Like, these are all really interesting aspects. And so I'm glad to hear that you guys are already sort of thinking forward as to how to integrate those bits into Kubeflow. So I wanted to take a question from the community. Rajiv is asking a question that I have as well. How well is Kubeflow supported comparatively on top of the cloud platforms, AWS, GCP, Azure? Is it better supported by any particular vendor, or what should people expect or look for if they want to deploy Kubeflow on their own cloud platform, not their private cloud, but obviously one of the big three?
Hey Raju, glad you asked that question, right? By the way, I'm from IBM, right? So it's best supported on IBM.
There you go.
But yeah, I mean, all the major cloud providers, right? Like including, us. If you go to kubeflow.org website, right, you will go and see that, AWS, Azure, GCP, they have very well documented instructions in terms of running on top of their Kubernetes offering, right? For the most part, in fact, what we see is most of the community requests are coming where somebody is running this on a cloud provider, right? So, obviously, Google is the core originator for Kubeflow, right? But currently, Amazon is heavily involved in terms of contributions as well, and they are working, very hard in terms of ensuring that, the integration of Kubeflow with AWS services is pretty solid. In fact, with one of our customers, we actually, the services team of IBM engaged in terms of getting Kubeflow running on top of AWS. That was Yara, which is, the largest, fertilizer company out of Norway, right? So they're running, for example, Kubeflow on top of AWS. And then there are quite a bit of customers with whom we are working who are running Kubeflow on IBM Cloud, right? And I would say, we have a pretty solid integration. And if you're interested, right, one repository which I would say is, if you're getting started, it's github.com/IBM/Kubeflow Dojo. Actually, takes that, very starter-based approach, starting from the scratch, going all the way, deploying it on IBM Cloud, and then, ensuring you're working with those services. But kubeflow.org website is your best choice, right? I mean, you would get very solid documentation from all the cloud providers. Yeah.
Excellent. And I discovered the IBM Kubeflow Dojo resource as well in preparation for this chat with you, and it was very helpful. So I'll make sure that we put that link in the chat here so that folks can take advantage of that resource as well. Well, that's great, Animesh. We're at 45 minutes. I just wanted to basically ask you a couple community questions before we sign off. What are ways that people can get involved in the project? I know open source projects are always looking for additional committers or people at least to try the project and sort of report issues that they find. Are there any other more focused ways that the community can be involved in the Kubeflow project that are especially meaningful to you right now?
Yeah, definitely. I think obviously we are looking for a lot of help, right? So I think one of the things with Kubeflow is, the sum is greater than the parts, right? So there are many parts, right? But the reason it became big is, getting this whole end-to-end life cycle in one single go through one open source project, and that's the piece, right, where I would say, quite a bit of help is needed to ensure that, that consistent way of bringing all the different Kubeflow components together, deploying them, managing them, upgrading them, remains solid as we move along. There is obviously more domain focused areas, like, if you are more interested in the serving side, production machine learning serving side, or, on the pipelines or in the distributed training side, these are all different work groups which have been formed. So if you go to Kubeflow / so in the Kubeflow GitHub org, there is a community, a project called community. If you click on that, there is a YAML file at the root of that, which is called workgroups.yaml or wgs.yaml. That has, all the different work groups which are listed, the people who are leading it, when are they having the meetings, right? And, point us to the Slack channels. So obviously, you want to be in the Kubeflow Slack workspace, and each of these projects have their Slack channels. But more importantly, if you're trying to figure out, which is the work group and the participating companies or the leading companies behind all these different domains, I would say, that's a good place to start to figure out. And, it has the email IDs, it has the people who are leading these. Plus, when the community meetings are happening for those specific ones, right? So you can join that.
That's great. I love it. You have your own YAML file for working groups. How meta. Well, I hope that you get a lot of interest in the Kubeflow project from this conversation. I know that our community is interested, and you might even get some committers, hopefully as well. But what's a good place for folks to get in touch with you, Animesh? Is the best place in the Slack group for Kubeflow, or are you on Twitter?
I'm on Twitter. Twitter is my first name and last name, right? So Animesh Singh.
Great.
That's my handle. So hopefully, it's easy to reach out. Definitely, my GitHub handle is the same, Animesh Singh.
Okay.
So that's another way, right? And definitely, I'm mostly available in all the Kubeflow Slack channels, right? If you want to reach out from that perspective. So yeah, looking forward to more contributors coming and taking this project to greater heights, right? We see an endless opportunity. We already have a huge number of enterprise customers, right, who are either using Kubeflow as a whole or parts of Kubeflow on which they have standardized. And I see, there is still a great amount of potential which needs to be tapped, right? And thing like, I was mentioning feature store, right, which has yet not become, total mainstream. But now we are seeing, next year we are seeing, quite a bit of customers, as they have now become more advanced. They're looking for something like, feature store, which can give them a consistent set of features which they can use for training, for their deployed models in production, and more technologies like that. Like, so there is a project called, CATIB in Kubeflow around hyperparameter tuning, but then there is an arm of it which is around AutoML, right? So neural architecture search. So a lot of more advanced areas, right, which are coming up. And, if you're interested also, more futuristic research oriented things, it's also a great place to come and work together.
Yeah, that's great. Well, I'm sure your Kodai group is always hiring. And so we'll put the word out for you amongst the community. I've seen lots of great engineers go through your group in the last bunch of years and contribute to awesome projects. So that's been neat to see. And yeah, it's been great to chat with you, Animesh. Thanks for taking the time to come and share with the community.
Thanks.